Mustafa asked if we could do a quick sort of overview about the domain name system, how it works, so at least for the non-technical people, they understand what the DNS is about. So I'm going to do this quickly in maybe 5 minutes. Of course, any questions are welcome. So, when you want to go to a website or send someone an email, you write an address, okay? And this address, like web address, normally it's in the form of xyz.com or something.net and so forth. In fact, computers do not understand names. They do not understand characters or letters. They only understand numbers. And that's why the name is transformed into a number, which is called IP address, or an IP, by the way, is not intellectual property. For lawyers, this is very confusing. It's Internet Protocol address, IP address. And then once the name is transferred to this address, the packets move from the source all the way to the destination, and then the response comes back. And through the way, the packets would take, different routes depending on, different aspects related to the engineering of the network itself and all this. Now, the transforming the name to a number and vice versa, this is what the DNS is about. It's very similar to the phone book. You know the phone book? When you open the phone book, you see names and numbers, names and telephone numbers. The DNS is the phone book of the internet. It has names and IP numbers instead of phone numbers. So this is, in a nutshell, what the DNS is. Now, how the DNS works? It works, in a structure very similar to a tree structure, okay? Yet the root of the tree is at the top, not at the bottom. Okay, so here's the root, and then we have what we call the top level, okay, layer or level of the domain name system. Top level domains like .com, the most popular, like .net, like country codes, .eg, .mus, okay, .tr for Turkey, UK, and so forth. And then second level domains, and this is the level where users like us, okay, normally sort of interact with. Okay, we register domain names at the second level. We may sell domain names at the second level. We buy domain names and so forth. And then there are, you can have as much as or as many as lower levels as you want. I mean, for example, you run ICANN.org. Okay, we run ICANN.org, in fact. So under ICANN.org, we can have as many lower domains as possible for different departments, different products, services, and so forth. Now, how each of those domains is run is entirely up to the manager. Okay, we normally call the domain sort of owner. Okay, is the root zone manager. Okay, he manages the root zone or the root zone of this domain, or the zone file of this domain. So depending on the policy of the manager of this of the particular domain name, he or she can decide on the kind of domains that can or cannot be registered underneath that domain, how many lower levels, and so forth. Now, top-level domains, they come in two sort of types, as Luca alluded quickly to, the country code top-level domains and the generic top-level domains. Generic top-level domains, of course, the most popular ones, .net and .org. Right now, we have more than 1,000 of these generic top-level domains, including very new domain names, like, for example, .bank, like for city names, for example, .nyc, New York City, .london, recently .dubai, got got delegated last week or the week before. Doha is in the pipeline and so forth. Many brand names decided to obtain their top-level domain name. Google, Toyota, maybe. I mean, there are at least 100 brand names that got their top-level domains. Country code top-level domains, they belong to the country. The country, has to decide on who and how to manage the top-level domain name, what kind of policy, what kind of pricing scheme, and so forth. 5 years ago, ICANN introduced top-level domains in different scripts. So we have top-level domains in Arabic, in Chinese, in Cyrillic, in Indian languages, Korean, and so forth, including, of course, Webmaster for the case of Egypt. Now, the root, what we call the root, is each top-level domain includes the zone file, and this is the phone book of this area of the DNS. So under .eg, for example, so the root, the zone file of .eg would include the second level domains that exist under .eg, like com, gov, edu, and probably there are 7 or 8 more second level domains. And what this zone file will include in that case is that com.eg has this IP address, could be more than one, edu.eg has this IP address, and so forth. And then for each one of the com, edu, etc., they have their own zone file as well. So as a user, if I want to go and visit, for example, ntra.gov.eg, okay, and I'm sitting here on this network, my query goes from my computer to the nearest DNS server that exists on this network, asking about the IP address of ntra.gov.eg, okay? In some cases, the IP address of the requested domain name is cached within the DNS server on the network. So in that case, the server will respond directly to the user, okay, this is the address, go and find your way. In other cases, it might not be in the cache. And in that case, the query about ntra.gov.eg will have to go to the root of .eg, okay? The server itself, unless it has it cached, it will not be able to tell the user, okay, this is the address, okay? But it can tell them that, okay, the root server, okay, is this one, okay? Go and ask the root. So the query will be directed or redirected to the root server, and the root server will reply saying, okay, .eg has this address, go to EG. And then the query will go to EG, and .eg will respond with, okay, .gov.eg has this address, go and ask gov.eg, okay? And then gov.eg will say, okay, ntra.gov.eg has this address. This entire process actually takes milliseconds, okay? So this is in a nutshell how the DNS works. Now, the root of the DNS, okay, includes information about all the top-level domains, generic and cisd, but it does not include information about ntra.gov.eg or even about gov.eg. It only contains information about .eg, about .com, about .net, and so forth. This is the root. And the root servers, there are 13 root servers, spread around the world. In fact, 10 of them exist in the US and 3 outside of the US, and they are run by 12 different organizations. And these organizations, by the way, most of them existed before ICANN existed. So, and ICANN runs one of those root servers. And each root has a name, and the name is a letter, just for easiness. So there's A root, B root, up to M root. ICANN runs the L root server, but in addition to our role in running the L root, we also coordinate the work among the root server operators, the 12 or the 11 plus ICANN 12, the root server operators. But the fact that there are only 13, or the statement that there are only 13 root servers is not technically correct, because there are more than 500 replicas of those 13 servers around the world. So in Egypt, for example, we have at least copies of 3 root servers, including one for ICANN and 2 others for VeriSign, and there's one more. So there are more than 500 root servers around the world. Now, and by the way, TAG, Talal al-Ghazala in Amman, they run one of the root servers as well. They host one of the root servers as well. And the good thing about hosting or having a root server, close to your location or to your network, is that it provides better response, although it's all we're talking milliseconds, but still it's a better response. And also in cases of disasters,
Yes.
and we experienced some disasters. I remember back in 2010 we had major cable cuts in Egypt, and we were almost disconnected for some time. So having root servers within the country help you as a user to reach your destinations that still exist within the boundaries of Egypt, but without having those root servers in Egypt, your queries wouldn't have been resolved because there are no root servers, and the entries themselves might not have been cached within your DNS. So having a root server within the country has many technical and non-technical benefits. My very last slide, since we mentioned the IP addresses, so the other part of the DNS system is IP addresses, as I said. Now, those who run and operate networks, like universities, like ISPs, like maybe government departments, like private companies, they need IP addresses for their networks, for their computers. Telecom Egypt to have a range of IP addresses. Now, ICANN is not the organization that provides those addresses directly to ISPs and network operators. We provide them via regional internet registries. And those regional internet registries, they exist in 5 different continents. So we have one in each continent. So in Africa, if you are an ISP in Africa like Telecom Egypt, you would go and get your addresses from Afrinet. Okay? In Europe and Middle East, they get it from NCC. In Latin America, they have LATNIC, APNIC in Asia, and ARIN in North America. So these are independent organizations. They obtain IP blocks from ICANN, and then they distribute those blocks to their clients according to policies that are sort of developed and agreed upon within the regions themselves. So ICANN does not interfere in policies pertaining to IP addresses within the regions. So this is in a nutshell the technical part of the DNS and how it works. It was quick, but I hope it was clear.
So clear.
Any questions?
Thank you very much.
I acknowledge that many of the people here are technical people. They can explain far better than me, so they will not ask questions. But do you have any questions?
No, I'm satisfied with it.
Any questions? Non-technical. Okay, thank you.
Thank you.